Separable differential equations. A separable differential equation is a first-order differential equation in which the expression for dy over dx can be factored as a function of x times a function of y. It can be written in the form of dy over dx equals g of x times f of y. In other words, you can separate all of the x terms and all of the y terms. An initial condition is a set of points that can be used to solve the c component in the differential equation. It can be given as y of 0 equals 4, or when x is 0, y equals 4, or as a point, xy. How will I use this in real life? You can use this to find trajectory, correctly mix solutions, and when dealing with electricity in circuits. Now here's an application example. A tank contains 200 kilograms of salt dissolved in 5,000 liters of water. Brine that contains 0.03 kilograms of salt per liter of water enters the tank at a rate of 25 liters per minute. The solution is kept thoroughly mixed and drains from the tank at the same rate. How much salt remains in the tank after half an hour? To start, you can list all of your givens. So y of t equals the kilograms of salt after t minutes. Y of 0 equals 20, which is the initial condition, and you're trying to find y of 30. dy over dt equals the rate of change of the amount of salt. And you can see that dy over dt equals the rate in minus the rate out. And you can solve for those individually by doing, for the rate in, 0.03 kilograms per liter times 25 liters per minute equals 0.75 kilograms per minute. And the rate out is y of t over 500 kilograms per liter. And this is because the tank always contains 5,000 liters of liquid, so the concentration at time t is y of t divided by 5,000. And then multiply that by the 25 liters per minute to get y of t divided by 200 kilograms per minute. So once you plug those back in, you get dy over dt equals 0.75 minus y of t divided by 200, which is simplified down to 150 minus y of t divided by 200. So then you begin to separate the variables by dividing each side by 150 minus y of t and multiplying each side by dt. Once you get those separated here, you can integrate both sides and you come out with negative natural log of the absolute value of 150 minus y equals t divided by 200 plus c. Now is when you use the initial condition, y of 0 equals 20. So 0 is t and 20 is y. So you plug in those values into this equation and you solve for c, which is negative natural log absolute value of 130. So then once you plug c back into the differential equation, you get negative natural log absolute value 150 minus y equals t divided by 200 minus natural log 130. So now you can simplify the constant and get rid of the natural logs, and you have to solve for y. So you do e to the negative on both sides, so you get e to the negative natural log absolute value 150 minus y equals e to the negative t divided by 200 plus natural log 130. And that gives you absolute value 150 minus y equals 130 e to the negative t divided by 200. And y of t is always positive because y of t is continuous and the right side is never 0. So you go up here and you want to solve for y of 30, so 30 is t, and you're solving for y. So you plug in 30 for t, and you solve it and get 38.1 kilograms of salt.